is not being done. When you say you have low TB screening in your facility, what do you look at? How can you justify that? What makes you feel, or what makes you conclude that TB screening is low in your facility? Those are the contributing factors.
Well, you find that there is the screening is not done because the presumptive register is not filled. Like, for example,
let me guide you a little more, Sophia. Let me guide you a little more. Yes. Okay, when you tell us because screening is not done because, that is a root cause. Yeah. You get me? But when you're looking at contributing factors, you are just justifying that specific problem. You're trying to unpack the contents. When you say low TB screening, of course, there are points where TB screening is supposed to be done. Yes. You get me? There are points where there are stations where TB screening is supposed to be, and I presume that every department TB screening is supposed to be handled to all patients, 100%. So for you to tell us that TB screening is not being done, it means that in those departments, TB screening is actually low and is adding up to our total problem. Do you get me? Yes. So you will look at the departments where TB screening is supposed to be done, from triage to endpoint, everywhere where TB is supposed to be screened. When you look at the data compared to now the workload, that is when now you can justify and say TB screening in this facility is low. You understand? Yes. We are not looking at the reasons why TB is not being screened, but we are looking at the justification of that statement of low TB screening uptake or coverage. So when you look at the departments, say CWC, you have 100 clients, but only 2 are being screened. You'll say TB screening is low here. Yes.
Well, I agree with you. It's not that it's not being done. It's suboptimal. It is being done, but it's suboptimal. And you find that the presumptive registers are also not documented in some facilities. Yes, totally not documented, which means that if it's not documented, it means it's not done.
Sawa. Thank you, Sophia. I hope you have understood. So we are not looking at the reasons.
I have understood. Yes.
Thank you. Thank you.
I understand. Thank you so much.
Thank you. Thank you. Yusra, can we move on?
Thank you. Yeah, I think there is somebody else who is raising hand, or we continue. Okay.
So should we give them a chance?
Kuresha will, at least a minute.
Thank you. Okay.
Kuresha. Okay, we continue.
Thank you. So, hoping that's a bit clear. So when you're looking at the procedure of situation analysis, we said we brainstorm on the contributing factors, just like what we've just done. Then you decide the period of data collection and the method of actually collecting the data. And then for the data that you collect, you're looking at the gaps in each contributing factor using a checklist. And this is the checklist that we use in data collection. So you list down all your contributing factors and then the period of data collection, and then you do your tallies and come up with the contribution of each factor. We'll see in an example. When we look at our first example of contributing factors, we talked about incomplete documentation of patients' treatment records. And we said that contributing factors are the contents. You're just trying to justify, why do you say you have a problem? So for a treatment record, a patient treatment record, for you to say that you completely fill or you completely document in that record sheet, there has to be the patient's vital signs, there has to be the medication that you are prescribing, there has to be laboratory test results, there has to be, of course, the biodata, the diagnosis, the radiology investigation. Factors, we are looking at the gaps. That is what we say. So in this case, we are looking at the number of cases where vital signs are missing. So you will do a sample of your recording or patient's treatment recording sheets. Let's say you pick 50 recording sheets in a span of like a month. Within a month, not in a span of within a month, you pick 50 recording sheets, and you want to find out the incompleteness in those documents. You will check in every recording sheet and see whether all these parameters listed here as contributing factors have been recorded or not. So you're looking at the vital signs. So now the number of cases where vital signs are missing, so you start tallying. Of course, when you're doing sampling for 4 weeks, you cannot pick all the sheets in 1 week. It has to be spread for fairness. So you'll check the number of times where vital signs are missing, and then you tally. Then you will check the information on prescribed medicine. Have they recorded the medicine that is supposed to be prescribed? Then you also check whether lab test results have been documented, just to ascertain the diagnosis. Then the patient's information, like the name, the weight, the age, perhaps, depending with the medication that you're giving. These are very important. And then you also check on the diagnosis itself. Then you can also check the radiology investigations and the code, the investigation code. All these are contents of a treatment recording sheet. If there is anyone that is missing, it means you're incompletely documenting in a treatment sheet. So these are the this is what is telling you we are not documenting these sheets completely. So these are the contributing factors. So once you do your tallies, you come up with the totals. The totals here will form the frequencies in our Pareto chart. We'll see in the next. So once you collect your data and you come up with the totals, you use the totals as frequencies, and then you come up with cumulative frequencies, and then now you develop the tool that we just mentioned called a Pareto chart. We will see in the Pareto chart. You remember we had the frequencies as our totals in the record, in the, what is this tool called? The recording sheet, where we did our data collection. And we said that the last column of the totals will give us the frequencies. So these are the frequencies. Yeah. And they have to be arranged in a descending order to be used in a Pareto chart. So why are we mentioning a Pareto chart? We are mentioning a Pareto chart because it is a tool that will enable us to actually concentrate on the contributing factors that are supposed to be tackled in step 3. There is a rule that says 80% of the effects of your problems are contributed by only 20% of the causes of your problems. That means when you look at your contributing factors and you get the 20%, which are actually very important, and you handle those 20%, then the effect will be seen in your entire problem. Then you utilize the data collected to develop a graph. The graph is what we call a Pareto chart. So how do we do the Pareto chart, or how do we develop a Pareto chart? A Pareto chart is a combination of 2 graphs, a bar graph and a linear graph or line graph. The bar graph is actually formed by frequencies, while the linear graph is formed by cumulative frequencies in percentage. And that's why we use this figure. So for our theme, we said documentation of patients' treatment records is improved. Our theme is supposed to be written in a positive way. So when we say incomplete documentation or low documentation, whatever that you want to say, perhaps the problem statement was internal medical ward had a problem of missing information in the patient's treatment records, which is affecting treatment of patients. So these are the contributing factors to incomplete documentation of the patient's treatment records. So we do our frequencies, which are the tallies that we did and got the totals, and they have to be documented. They have to be written in a descending order in this table. Then from these frequencies, we come up with cumulative frequencies. How do we get a cumulative frequencies? Of course, for the first row, the cumulative frequency is just picked from the frequency itself. Then the next cumulative frequencies is actually the frequency, added to the previous cumulative frequency or the first cumulative frequency, then you get the second cumulative frequency. For our example here, our first frequency was 45, which we picked to the cumulative frequency. Then the second frequency is 25. If we want to get the second cumulative frequency, we take our 25, we add it to 45, the previous cumulative frequency, to get 70. Then we continue like that. The third one is 8, we add it to 70 to get 78. The third one is 3, we add it to 78 to get 81, and up to the end of the table. Once we have our cumulative frequencies, then we convert these ones into percentage. And we said the percentage cumulative frequencies are going to be used to form to document a line graph in a Pareto chart. We will appreciate it when we reach the graph. So how do we calculate cumulative frequency in percentage? You take the cumulative frequency, divide it by the grand total of the frequencies, then you multiply by 100. So if you take 45, divide by 86 times 100, you'll get 52%. The next cumulative frequency in percent, you take 70, divide by 86 times 100, you'll get 81. And so on and so forth up to the end of the column. Of course, the last cumulative frequency in percent should be 100%, because it is the last cumulative frequency in the table divided by the grand total of the frequencies, which is the same number, and you get 100%. I hope that's clear. Huh? So once we have unmute. Thank you. So once we have our frequencies and cumulative frequencies in percentage, we said we are going to plot two graphs, a bar graph and a line graph. The bar graph is actually from the frequencies. The highest number here in the, is this supposed to be X or Y axis? The vertical one is formed by the frequencies. And the highest frequency is 45. So this will be our topmost number, 45. Then the line graph is formed by the cumulative frequencies in percentage. It is also called accumulation ratio. So our first bar will be up to 45. Our second bar will be up to 25. The third one is up to 8. We are comparing with the frequencies up to the last one. Then when we come to the line graph, we are looking at these percentages here. And the first percentage here, the first contributing factor, is at 52.3%. So we come to this far end, the far right of our graph, and look at 52.3%. Then we plot against the first contributing factor. For the second one is at 81%. We go to 81% and plot on the second contributing factor. We do the same to the rest. For each contributing factor, you plot the percentage on the bar, or maybe to be aligned with the bar up to the last figure. By doing so, you will have come up with two graphs, a bar graph and a line graph. Then you join the dots of the line graph. So when we mentioned about the Pareto, we talked about 20-80. I hope everyone remembers that. And we said that 80% of the effects of